Okay, so today we are going to start our cells unit by talking about microscopes or microscopy. So the microscope itself is the instrument that we use to view objects too small to see with the naked eye. So microscopes used to view things that we can't see with our eyes. Magnification is going to be making an image appear larger than it actually is. One thing we'll run into in this unit is resolution, which is how clear something looks. Sometimes looking under the microscopes, things don't appear that clear, so you have to figure out what the problem is to try to make it appear more clear. The field of view is how much area you actually see when you're looking under the microscope. And the depth of field is the thickness of the specimen. So you'll notice that sometimes if you're viewing a specimen that can be kind of thick, maybe like part of an insect, you can only make one part of the insect leg or appendage look clear at a time, because the appendage has many different levels of organization, and you can only clarify one at a time. We're also going to be using a few different microscopes in this class. The first and the simplest is the dissecting microscope. The second and the most common one that we will use is the compound or light microscope. So compound and light. You can go by either name, microscope. Two that we will discuss, but we're not actually going to use, and that I've actually never used because they are very, very pricey, are the scanning electron microscope as well as the transmission electron microscope. All right, so now we're going to go through each of those each of those four and discuss a little bit more about them. So the dissecting microscope uses a light, and it's going to create a 3D image. The dissecting microscope is relatively low magnification. Oftentimes, these are going to be used during dissections. That's why it's called a dissection microscope. And it just helps to get a better view of a certain specimen that you're trying to see. So, for instance, if I was looking at a fly, I can see a fly with my eye, but I can't see all the little details on a fly. But if I were to look at it using the dissecting microscope, I can get much better visualization of this fly. It can also be used to view parts of organs better. It can be any type of dissection, but it cannot view individual cells. So using the dissection microscope, you cannot see individual cells. You can only see larger tissues. And this is the image of a dissecting microscope here. It'll be the simplest one that we see. All right. Microscope type 2 is going to be one that you're probably more common seeing and even using, and that is the compound light microscope. It is called the light microscope because it uses light, and it's called the compound microscope because it uses two lenses. You have the lens that you look through, that you put your eye against, called the eyepiece. And it also has objective lenses, which are the ones that you rotate into place. So compound microscope uses 2 sets of lenses. The magnification on these range from 10 times magnification to 400 times magnification, and these are used to view cells. And because we're in biology and we're going to talk a lot about cellular biology, these are typically the ones that we'll use in the classroom. All right, now on to electron microscope in general, and then we'll break it down into the specific types that we mentioned. Electron microscope electrons to images of objects. So it'll blast electrons in, and the electrons will bounce off to form an image. These have magnifications up to 10 million times larger. So this is a much, much higher magnification. And if you look at this microscope here, you can see that yes, it's much more complex, and it's going to allow you to view things that are much, much smaller. And this can only be used on dead cells. And electron microscopes are going to be what helps us visualize things like DNA. Now, we mentioned 2 different types of electron microscopes. We mentioned the transmission electron microscope. These are going to beam electrons through thin specimens, and these are going to create 2D images. So they're 2D images, and they can only be used on thin specimens. While the scanning electron microscope is going to be a whole thing, it's not going to be sliced, it's not going to be a thin section, it's going to be a whole object, typically plated in gold, and electrons are going to bounce off of the specimen. So I'm going to write whole specimen. And this is going to help us have a 3D image. So if we look at the 2 images here on the PowerPoint, these are 2D, they're flat because we're only looking at thin slices or sections, versus the one at the bottom, it's the whole object visualizing, and therefore 3D view of the image. In order to properly use a microscope, you're going to have to be familiar with the parts of the microscope. So we're just going to go right in order. Here, number 1, the body tube. Number 2 is the revolving nose piece, because the nose piece is actually going to rotate. That's why I call it revolving. I mentioned earlier that we have objective lenses which you can rotate into place. We have the low power objective, which will be the shortest one. We have the medium objective, which is the one that's the middle length. And then we have the high power objective, which is the longest one. Number 6 here is pointing to the little clips that are going to clip our slide into place, and they're called stage clips. Number 7 is pointing to this object here, and that is called the diaphragm. The diaphragm is going to adjust the amount of light hitting the specimen. Number 8 at the bottom is going to be the light source. It's what projects the light upward. Number 9, here where you put your eye is the eyepiece. And the eyepiece is your first lens. Number 2, when you carry the microscope, you're going to hold the arm with one hand and support the other hand here at the base. Number 11 is this whole square here. That is the stage. The last 2 are our 2 knobs, and these are going to be what makes our specimen come into focus. The first one is the coarse adjustment knob. And that's going to make large changes. I turn this and it makes large changes in my view. Versus the small one, that's the fine adjustment, which is going to make very small changes to my view and to the clarity of the microscope. So I know that we're not in person, but I'm going to describe how you use a microscope in person. You know how to work it, and you can in the event that you are going to do a lab with microscopes. So the first thing you're going to first create your slide. So you're going to have a slide. You want to be sure that when you get a slide that you inspect it to be sure that it has no bubbles. Because sometimes if you're looking under a microscope, you might look at something and you're like, ooh, that's very interesting, but you actually are only looking at an air bubble and you don't want to do that. You're going to go ahead and put your slide right under the stage clips and try to center it in the light. So you want to be sure you turn your light and microscope on. Put your slide on, make sure it has no bubbles, and center it in the middle of the light. You also are going to want to be sure that you have the smallest objective clicked into place. So you're going to click in your smallest objective so that it's right over top of the specimen. And you are going to turn the coarse adjustment knob until your stage is as close as it'll get to the objective lens. So you want your stage to be all the way up. You can do that before you even look into the eyepiece. You should do all of that before you even look into the eyepiece. Once you have your stage all the way up, you will put your eye at the eyepiece and look into the microscope. Things should not be that clear right now. Then you're going to start slowly turning the large coarse adjustment knob until things become a bit clearer. When you get them as clear as you can on the coarse adjustment knob, you stop. And then you're going to move to the fine, small adjustment. Here you're going to make very fine changes until your specimen is as clear as you can make it. Once you have it clear using the smallest objective, then you may turn to the medium power objective. You don't touch anything. So don't touch the adjustments. Once it becomes clear, then you're going to turn your objective to the medium power objective. You will look through the eyepiece again. Things may not be clear. At this point, if they are not perfectly clear, you are only going to touch the fine adjustment knob to make small changes. Once you are focused under the coarse adjustment knob for the first time, you never touch it again. You change your objective, you only use the fine adjustment. That's one of the most common things for students to not be able to find their specimen on the other objectives is because they touch the large adjustment again. So you never touch the coarse adjustment knob, you never touch that big knob again if you're not on the low objective. Okay, now we're going to need to be able to calculate total magnification of a microscope. Because a compound microscope has two lenses, it's going to require a mathematical equation to figure out the total magnification of the overall microscope. The total magnification of the microscope is going to be the magnification of the eyepiece. You might also see eyepiece as ocular, times the objective magnification. The eyepiece is always going to have a magnification of 10 unless it says otherwise. So the magnification of the eyepiece is always 10 unless it says otherwise. So here's your eyes you look through, the lenses are your objective lenses. Again, eyepiece is always 10 unless you're told otherwise. However, it's going to have it written on the eyepiece. It'll say 10x. And then the objectives, if you look on the objective here, this one is a 40x. This one is a 4. And I don't know if you can see it way back there, but that's a 10. So it's always written on the microscope itself. So, I'm going to scroll down and we'll do this problem down here. So again, our total magnification is equal to our eyepiece. Oof, I can't write. Times the objective. So that's our equation. All right, this problem, if the total magnification is 400x, what is the magnification of the objective lens? So we're going to go through and fill out what we're given. The total magnification is 400. So my total is 400. 400 equal to eyepiece times objective. Earlier, we stated that the eyepiece always has a magnification of 10 unless you're told otherwise. So we're going to do 10 times objective. Now I just have to solve my equation. The way that I do that is 400 divided by 10 equals the objective. 400 divided by 10, it simply comes down to taking off a 0. So 40 over 1, 40 times magnification is my objective. So that's how you would work that equation. All right, so it looks like I forgot to fill this in. You always start on your low objective with the stage all the way up. Apologize about that. Now, you're actually going to also be tasked with creating your own wet mount slide of your specimen. And the way that you're going to make a wet mount slide is first to get a clean slide cover slip. The thing I do want to mention before you do this in person is that these are glass, meaning they can break. The cover slip may appear like plastic, but it is not. It is very thin glass, meaning if you try to bend it or you put pressure on it, it will break and could cut you. So be very careful of your slide as well as your cover slip because both are glass. So once you have your slide and your cover slip, they need to be clean. Make sure both are clean. Then you're going to place your specimen in the center of the slide. So whatever you're going to view, you place it in the center of the slide. Once you have your specimen in the center of the slide, you're going to place 1 drop of water on top of the specimen. 1 drop is fine. If your specimen is hard to see, you'll use a stain. We're not going to use stains in this class, but in other biology classes may require staining. After you have your specimen with the drop of water on top of it, you're going to take your cover slip and hold it at a 90-degree angle over the specimen. A 45-degree angle. So you're going to hold it at a 45-degree angle above the specimen. So it'll look like this. And then you're going to let it drop. Again, do not try to bend it on there. Sometimes students will try to bend it down on there. Just literally hold it at an angle and let it go. If you try to bend it, it will break. So you hold it at a 45-degree angle above the specimen in the water, and you let it drop. The reason you use a 45-degree angle is to prevent air bubbles. If you were to hold your cover slip perfectly flat up here and drop it down, air would get trapped. Versus if you hold it at an angle and then drop it, the air is going to be forced out and should not get trapped. You do not want your specimen to be under an air bubble, or you're not going to be able to view it properly. All right, thank you. There will be some practice labeling on Canvas, so go ahead and check that out.